Hello again, back at you in chapter 8. This is looking at a really interesting situation of hitchhiking and linkage disequilibrium. So, one way to detect whether natural selection occurs is by looking at the regions around an allele that you believe to be selected for. So, in this example, we have a star, and that star shown here is just one of many alleles out of many individuals in the population where this mutation occurs. And it has some adaptive value. It allows people to have more offspring than those that don't have this mutation. And let's look at it. You see here over in blue, that's not an adaptive mutation. It just so happens to be an allele for another locus that it's closely associated with. So when, and then over to the right is this green thing that is another allele that is in the same basic region. So as selection occurs over time, we see that now the population has many individuals with this favorable mutation. There are a few that don't, but this is strongly selected for because most of the population does have it. And then what we find out is that these alleles for the different loci travel along with the star. So all of the stars also have the blue and they have the green. This suggests that this region of the gene has been selected for, and that there hasn't been enough time for recombination to break this apart, because eventually, if these two individuals were to have children and there might be a recombination event right there, then all of a sudden you'd have a star with a dark blue. And but that just there hasn't been enough time yet for that to happen. And as we know, recombination between two genes that are or two loci that are very close together does not occur frequently. So you need a lot of time for that to be broken down. So let's look at an example of lactose tolerance. And here we see that there are some regions of the world where the frequency of lactase is persistent. Now, what that means is that ordinarily, uh, after a baby stops breastfeeding, doesn't have any more milk, there would be no reason to produce the enzyme lactase, which breaks down the lactose into fructose and galactose. However, in regions of the world where they have cattle dairy, then all of a sudden we can drink mammalian milk from a different mammal, cow's milk, that still has lactose in it. Well, for those who have the lactase persist, the enzyme persist past childhood, they can eat milk products without a problem. However, for those that um, have lost the production of the lactase because it's frankly much more efficient not to be able to have that enzyme because you're wasting time making an enzyme that you would never need again. However, um, for those individuals who don't have the lactase gene turned on in adulthood and they have milk products, they can have severe indigestion by drinking milk. So what they've done is they've looked, okay, there's this region in Africa. We can see that this is the hot spot of the dairy area. And then as we move out, we can see that the persistence um, gets smaller. And we also see a hot spot here, and we see a hot spot of lactase persistence over here. These happen to match areas of the world that also have dairy farming. So when we look at these regions of the world, Africa and Europe, and we then look at this region of individuals who have the lactase enzyme still being produced after childhood, we see that there's this mutation, a G to a C, at 14014 in a particular gene. Now, when we look at this green region, that means that all of these individuals share this original green region. Whereas when you look at the pinks, you can see that they share very little. So what this suggests is that since this is so heavily green, is that this is a selective sweep, so that alleles close by to this substitution, GC, were selected for in this sort of big region right here, even though there was only this one GC right here at position 0 that made an impact. So they also looked at another population, this time Europe and Asia, where you saw those two hot spots. They have a different mutation, a C to a T at 13, 9, 10. So a different region in the gene, but it produces the same phenotype. It enables lactase to persist after childhood and therefore break down lactose. And again, when you compare those individuals who have the lactase gene persist, we can see that they have large swaths of the genome, or not of the genome, but of the gene of this region that are the same, that are similar, versus those who have not, they don't. And so this does in fact suggest that there was a selective sweep in this region for having the lactase enzyme persist through adulthood.